today you're going to be watching a quick video to review some properties to help you do the parent functions. But before we do that, I just want to make sure in review to remember to be fit, focus involved, take away any distractions, and to make sure you check the tech, which means all your tabs are closed, electronic devices are put away, cell phones you're not answering or texting, and headphones are in if you're listening to this video through the headphones, but you're not listening to music or anything else. You're in a room, quiet, with your Precalc packet out and open, and a pencil, and you're ready to be engaged. So here we go. Remember also that you can fast forward, rewind, and pause if needed. So this is not in your packet, this is just a review. If you remember domain and range, go ahead and fast forward. If you need a little refresher, just remember the domain is considered to be the independent variable, which goes along with the x values that give you real output or y values. Your domain here, you can see on the graph, is from left to right, which is your x-axis, is also from left to right. Okay, and then if you look at your range of a function, it's going to be the dependent variable, also known as your y. And for the y-axis, we look low to high, where the function is defined. So, reviewing that, let's look at these 4 examples really quickly. Again, this is not in your packet, just kind of look and understand, make sure it makes sense. If you look at the first one, let's do the domain. All of these are functions, right? They pass the vertical line test where no x values are repeated. So, domain, left to right. This is the leftmost x value, which is -3. Now, we're going to write this in interval notation. Okay? We use the square brackets when it's inclusive, meaning the point is included in the function. This is a closed point. We use a parentheses when it's exclusive, okay, if there's an asymptote or a hole, okay, or it's infinity. So this is included -3, and we look to the right. The rightmost x value is +3. Done. It's continuous, all values in between -3 and +3. If you look at your output values, your range, the y values, your lowest y value is at -2, and your highest y value is +2. Done. Let's look at number 2. Notice we have arrows here. Okay, so we're looking at the domain. The leftmost goes on and on and on forever. So that's -infinity. Whenever we use infinity or -infinity, we use the parentheses because it's not a specific value. Okay, if we look to the right side, this is going on and on and on forever on the right side. So that's to +infinity. Kind of the same thing for the range. This technically is your down, your lowest point. This is going down, okay, to -infinity. And also along the y-axis, this is going up, okay, to +infinity. Done. Let's look at number 3. Domain, left to right. We start leftmost first, which is here. That would be at -4. This point is included, so it's a bracket. Notice we look to the right over here, we have our arrow going on forever. So that's to +infinity with the parentheses. Your range, if we look at the lowest y value, that would be at 2, and that's again included. And if we look to see up, this technically is slowly going up and up and up to +infinity. Done. Now, 4 is a little different. You have a table. So here, because it's not continuous, it's a set of points, it's going to be set notation. Okay, not interval notation, which is with these squiggly brackets. So you can see your x values are 0, 2, 4, 8, and 10. So that would be your domain. Your range, you can see your y values repeat, but that's okay, it's still a function. We usually like to put them in ascending order, so starting at -1. You see that +1 appears 3 times. You only have to write it once, and then a 5, and we're done. Okay, so kind of 4 different examples of how to do domain and range with the specific notation that you need to know. Another thing you need to know is whether or not a function is continuous. Here you can look on this graph and you can see this is a continuous function. Now in your packet it'll ask you for the continuous interval. So you're looking for an interval, which means you want interval notation. Okay? So if it's continuous across the entire graph, the continuous interval would be all real numbers. Okay? Here, there's 3 different types of discontinuity. We have whole or point discontinuity. The second one here, we have jump discontinuity, and the third one here is asymptote, or you might have heard of infinite discontinuity. But you can still say where the continuous interval is. You just have to break it up. This would be negative infinity to 1, non-inclusive, and then in union with 1 to infinity. For number 2, the continuous interval would be negative infinity to 0, in union with 0 to infinity. And 3, the continuous interval would be from negative infinity to 2 in union with 2 to infinity. So when you have that property in your packet, that's what they're asking for. Where is the function continuous? On what interval? Okay, and we're looking for, when we talk about the interval, we're talking about the x values. Okay, where is that? So that's continuity. And then another property you need to know is increasing to decreasing. Again, they're going to be intervals, so we look at the x values and we read the graph from left to right. Very, very important. So you can see if you start here left to right, this is increasing. Okay, then this is constant, which means nothing's changing. It's not going up or down. Increasing, decreasing. Okay, so if we look at number 1, identifying the increasing and decreasing intervals. We start at the leftmost point. You can see this little ant is walking up into this point. So it's increasing, x values, negative infinity, up until negative 3. This is an included point. Now you can put a bracket or parentheses, it doesn't matter. Some people say at this point that it's neither increasing or decreasing. I will accept this, or negative infinity to negative 3 inclusive. Then it starts to decrease. The ant would be going down. Okay, so that's decreasing from negative 3 to positive 1. At this point, it starts to go back up. So another interval would be from 1 to 4. Okay, in union over here. And then we have a constant. It looks like, excuse me, it flattens out from 4 to infinity because we have an arrow here. So this would be our answer. Okay, keeping in mind you can use these hard brackets if you want to as well. Okay, let's change the color for 2. And let's read it from left to right. That did not change the color. There we go. Okay, so this is increasing. Again, we look at the x value. So it's increasing from negative 4 to negative 1. It continues to increase, right? Your y values are still getting larger. Okay, so we need to go back and fix that and make that negative 4 to 1. Then at this point, it starts to decrease. It goes down from left to right. From 1 to 3. Again, it's x values. Okay? Rewind that if that didn't make sense. Moving on to end behavior. End behavior is exactly what it sounds like. It's the end behavior of the graph. Left and right. Left and right. So this is left end behavior, right end behavior. Okay? We're looking at the x values. As x gets really, really small, towards negative infinity, where is your function going as x goes to negative infinity? Well, this function is going up, so that f of x, or y, is going to positive infinity. Whereas your right end behavior, so this was left end behavior, right end behavior is when x goes to positive infinity. Where is your function going? On the right side, you have an arrow over here on the right pointing downwards, so that's f of x, wrong notation, f of x approaches negative infinity. All right, let's look at 2. You can notice on both the left and the right side, they're both pointing up. Your y values are going to positive infinity. So, left end behavior, as x approaches negative infinity, f of x goes to positive infinity over here. And the right end behavior, as x approaches positive infinity, f of x goes to positive infinity. Make sure you understand this notation and use it every single time, okay? And then let's look at number 3. Your left end behavior, this is the left side of the graph. You have an arrow that's approaching this asymptote. This asymptote is when y equals 1. So as x goes to negative infinity, f of x approaches the asymptote at 1. Okay? Where the right end behavior, as x approaches positive infinity over here on the right side, where x is getting larger, again, the y values are approaching this asymptote at 1. Okay? Alright, 3 different types of end behavior. Now, this is in your packet, so make sure you have your packet out and opened to your number 1 linear function. I would like you now, we'll graph it together, make a table of values, okay? So this is y equals x. So if x is negative 2, y is negative 2. Negative 1, negative 1. 0, 0, 1, 1. Whatever x is, so is y. We all know what the line looks like. Okay, now take a second to fill in your domain, range, where is the function continuous, where is it increasing, where is it decreasing, is it even, odd, or neither? We'll kind of talk about this a little bit more tomorrow. Symmetry, is it about the origin, the y-axis, a specific point? Is there any absolute or local mins or maxes? Make sure you label if they are. And behavior, get the right notation, any asymptotes, and we already sketched the graph. So take a second and pause the video right now and complete this problem. When you're done completing it, hit play, and I will have the answers up on the next slide. So hopefully you've gotten these answers correct. Take a second to check them over. Your domain's all real. Same thing with your range. It's continuous across the entire graph, which is negative infinity to positive infinity. This is also increasing the entire time from left to right, never decreasing. This is odd because it's symmetrical about the origin. There are no local mins or maxes. The left end behavior, as x goes to negative, so does y. As x goes to positive, so does y. No asymptotes, and we have our graph. At this point, I would like you to try and graph, fill in the table, your corresponding y values, graph those points, and complete your properties. Pause this, complete it. When you're done completing it, hit play and we'll go over the answers. Okay, so looking at this graph, we have our parabola, which is the quadratic function. Your domain is all reals. Your range is 0 inclusive to infinity. It's continuous across the entire domain. It's increasing from 0 to infinity, decreasing from negative infinity to 0. It's even because it's symmetrical about the y-axis. You do have an absolute and local minimum at the point 0, 0. This is absolute and local. Make sure you had both of them, okay? And behavior, they both go to positive infinity, and there's no asymptotes. All right? Okay, now I want you to try 3 and 4 and graph it, fill in the properties. We're going to check these answers with your group tomorrow in class, and the teacher will also be coming around to check to make sure that you filled in the notes 1 through 4 by watching this video. That's the first thing you need to do. Then you need to go on to Edline or Google Classroom and watch the form and submit it by midnight tonight. That goes along with this video. So please do those 2 things right now, and we'll see you tomorrow in class.